This is Chapter 10, Section 3. We're going to look at modular arithmetic. For those who are older may remember the Mod Squad. I always think of this when covering this section, the Mod Squad. But this is modulo arithmetic. So it's very similar to clock arithmetic, but you're going to use a 0, take for instance, instead of 12. If it were modular 12. You would use a 0 instead of 8 if it were, say, clock 8. So forth and so on. So it's very similar to clock arithmetic. The days of the week are an example of a modulo 7 system. So here's the definition, and in doing problems you always want to go back to this definition. A is congruent to B mod M if and only if. IFF stands for if and only if. A is congruent to B mod M if and only if. A is divided by M has the same remainder as B divided by M. So you could use that definition with this A congruent to B mod M. Another one, if and only if, and here's one that a lot of people will use, M divides A minus B. So the second and third one are the most popular. So you have two different ways to approach these problems. So again, always go back to the definition. And I would use either A divided by M has the same remainder as B divided by M, or M divides A minus B, either one. So example, true or false? 21 is congruent to 13 mod 2. Well, one way, 21 divided by 2 has a remainder of 1. 13 divided by 2 has a remainder of 1. So either way, they both have a remainder of 1, so therefore they are congruent. Mod 2. 21 is congruent to 13 mod 2. The other way to do it, does 2 divide 21 minus 13? Well, 21 minus 13 is 8. 2 does divide 8. So you see, you could have done it that way also. Here's another example. Is 20 congruent to 5 mod 7? Well, 20 divided by 7 has a remainder of 6. 5 divided by 7, 7 goes into it 0 times. What's remaining? 5. 6 and 5 are not the same answer, so this is not true. This is false. Going the other way, what's 20 minus 5? 15. Does 7 divide 15? The answer is no. So either way, 20 is not congruent to 5 mod 7.